Hi friends, welcome to my another video. In my previous video, I have placed the power outlets and the light fixtures in a 2 BHK flat. After that, I referred important point mentioned in the DEWA regulation related to the power outlets and related to the light fixtures. Then we make the circuit based on the DEWA regulation for the power outlets and for the light fixtures. In this video, based on the circuit formation for the light circuit and for the power outlets, we will make the load schedule. But to make the load schedule, we have to write the circuit number in the layout. So let us start to mark the circuit number for each circuit, because in my previous video, for example, I wrote only DB. I didn't mention it is which circuit. It is a blue circuit, but which number of blue circuit. So it is blue circuit which have a number 2. So in this video, first we will make the marking for the circuit number, and then we will tabulate the all loads in a DEWA load schedule format, and we will try to balance all the load and we will finalize the load schedule. So let us start from the kitchen area, bedroom area side. Before that one, I want to tell you one thing, that in the load schedule, my intention is that first circuits will be for the power, and then the circuits will be for the light, and then we will make one more column for the power circuits. This is first I think, and accordingly I will prepare my load schedule, but obviously this will comply the DEWA regulation standard. So let's start this one. Here I wrote a circuit number R1. This circuit I already made in last video, so no need to explain again. So I made the circuit number R1, okay, for the general purpose socket. Then we make the circuit number R2 for the kitchen general purpose socket, and we mark the circuit number R3 for the oven, and we mark the circuit number R4 for the microwave. Here, during marking the circuit number, you have to think two things, that the load which I am marking the circuit number, it should lies under the same category. Meaning here, if you will observe that I mark the circuit number for the general purpose socket only, because general purpose socket lies in a same category, and the ELCB for that same category load will be same. In this case, it will be 30 milliampere. Suppose I'll tell you one thing, so you will not make mistake. Here I will write there is a FCU, and I will write instead of R4 for microwave, I put the R4 circuit for the FCU, then it will be a mistake. Why? Because circuit are lying in those circuit which required a ELCB rating of 100 milliampere. So always think before giving the circuit number to the load that the subsequent numbers is coming in the same ELCB rating or not, sensitivity rating or not. Okay, hope you are clear now. Now we will find there is any R load more in the power layout. Yes, we have in the laundry area, which is for the washing machine. So we put the circuit number for the washing machine as R5. Okay, we don't have now any other R circuit. So let us go for the Y circuit. We will again start from the one. So here for the for the power socket in the living and dining area, I put the circuit number as Y1. Apart from that, you check, is there any Y circuit? No, we don't have. Yes, we have one more Y circuit, which is hob, which is I mark as Y7. Here I want to highlight one important point, that I gave you a trick in the last video, that in order to balance the load, always identify the largest load in that flat and don't use that phase for the other circuit. Here also you will observe I use Y phase for the largest load, that is hob, and I use only one yellow circuit in entire flat. I made one mistake also here, which I will discuss at the later stage. So you will know how to do the try and trial rectification during the load schedule balancing. That will be the different case. Now we have given the circuit number to Y phase, that is Y1 and Y7. As I told you in my beginning, that I will make a load schedule in that the first circuits will be for the power, then will be for the light, and there will be again for the power. That's why I mentioned Y7. Okay, just after Y1 I wrote Y7. This you will understand when you will make a practice for the designing. Okay, now let us give circuit to the B phase. So start from the master bedroom. I given a circuit number to master bedroom sockets B1 to the bedroom 1 B2. Okay, as it is a ring circuit, so I mark both sides B1 B1, B2 B2. Okay, here we use two blue circuit, one for the water heater and one for the circulation pump, so I write B3 and B4. Okay, if you will check other, then we have one telephone panel that required one power, so I given B9. Hope you are clear till here. Now we will go for the light circuit and we will give the circuit number marking for the light circuit, as the FCUs are coming along with the light circuit because the sensitivity rating for the FCUs is 100 milliampere and light is also 100 milliampere. So we will give the circuit number marking after giving the marking for the light circuit. Then we will come again to this power layout and we will give marking for the FCU. Here I want to highlight one important point also. Before going to the light layout, we have to mark till which circuit number we mark the load in the power layout. So we mark the load for the R phase till R5. For B phase we mark till B4, means B1, B2, B3 and B4. And for Y we mark the circuit number Y1 and Y7. Here for the hope I wrote the circuit number Y7. There is other reason also to not write Y2. Why? Because Y1 is a general purpose socket load which is fed from a ELCB of sensitivity rating 30 milliampere. But the hope in the last video, when I refer the DEWA regulation, I clearly told you that for the hob or cooker we need a ELCB rating of 100 milliampere. So we cannot give subsequent circuit number, because if we will give Y1 to Y2, then the might be the ELCB rating will be the same, but we need two different ELCB rating, sensitivity rating of the ELCB. So here we have to note that we have given the circuit number till what number for the R phase, Y phase and B phase. Now this is the light layout which we prepared in the last video. We have done the circuit formation for the light layout in the previous video. From the previous discussion, I make the marking that R phase we have given till R5, Y phase we have given to Y1 and Y7 and B phase we have given till B4. Now this is the light circuit and the first one is the power circuit. So the sensitivity rating for the ELCB will be different. In that case, in the power case, it would be 30 milliampere, but in this light circuit, it will be 100 milliampere. So we have to start the circuit from R6, because if we will choose Y5, then the power, this R5 will be required 30 milliampere ELCB, but the Y5 will require 100 milliampere circuit breaker. So in that case, we cannot do that one. So we have to start from R6. Okay, so I have started R6 to the kitchen, maid room, maid toilet circuit. Then we will check any other R phase load is there. We don't have any other R phase load. Then we will go for the Y phase. We will start the Y phase again from the Y6, because we started R phase from R6. Okay, so we have given to the leaving area Y6, and we have one more Y6 circuit, that is Y8. Why Y8? Because Y7 already we allotted to the hood which is coming, which is having the ELCB rating of 100 milliampere. We can fit this R6, R7 and Y6, Y7 and Y8 under the same ELCB. So we given the circuit number to the laundry area, store area and the flat passage to Y8. Hope you understood this concept. Okay, this is very important to observe that one. Otherwise you will make many mistakes during giving the circuit number to the flat circuits. Now we will check, is there any Y phase? We don't have any Y phase other than this 2 Y phase. Then we will start B phase. B phase also we will start from B6. Okay, so we have given B6 circuit number to the master bedroom, its toilet and its corridor. We will give B7 to the bedroom number 1. Okay, now we don't have any other circuit to give circuit number. So we have done with the circuit number for the power layout and for the light layout. Hope you are clear till here. And I also highlighted during my discussion what are the common mistakes people are making and how to overcome this mistake. Hope. Now let us tabulate all this circuit number with its room detail. Here we see that the R1 circuit is here, which is in the maid room. So I wrote maid room, and this R1 circuit is feeding maid room and the kitchen socket. So I wrote the room number for R1 circuit, maid room and kitchen. How many sockets are there? 1, 2, 3 and 4. So total 4 single socket, which I mentioned here. 13 ampere single socket, 4 NOS. In same way, we have to tabulate all the rooms and their loads. For example, here Y1, if you will see, it is a living room power socket. So I put the living and dining room Y1 circuit, and how many sockets are there in the living room? 1, 2, 3, 4. Total 4 socket. 13 ampere single socket. In same way, for the master room, it's B1 circuit, and how many sockets are there in the B1 circuit? 2 plus 2 plus 2. Total 6. So I mentioned here 6. Now again go to R2 circuit. Here you see that there is R2 circuit for a kitchen, general purpose socket. So R2 is kitchen, and total number of socket is 4. 2 socket, which is twin socket, so it will be considered as a 4 single socket. Okay. Y2 we haven't given to any of the circuits, because after Y1 we came directly to Y7 here. I hope it is clear to you, which I have given to Hob. So Y2 is spare. Now let us go to the B2. B2 I have given to a children room, general purpose socket B2. So I wrote here B2 is bedroom socket. And how many sockets are there in the B2 bedroom? 2 plus 1 3 plus 2 5 plus 1 6. So total 6 single 13 ampere socket. Now let us go to R3. Okay, R3 I given to oven. Okay, so I wrote kitchen and the load is oven. In this case, it's not a 13 ampere socket, it is a oven. Okay, so I wrote here kitchen is the location and the load is oven, which is 1 NOS. Then Y3 I have given to spare. Why? Because after Y1 I directly use Y7. Now let us go to the B3 circuit, that is for the laundry. So go to laundry, and you see that the B3 circuit is for water heater. So I wrote laundry and the circuit is water heater. Laundry circuit is water heater. Hope you are getting this one. Now we will go for the R4. R4 I have given to the microwave. So I wrote R4, it is in the kitchen and it is a microwave. MIC is microwave short form. Okay, then we will go to the Y4. Again, Y4 will be spare because after Y1 directly we use Y7. So B4 also is a spare. You will not find here in the circuit. Then we will go to R5. R5 is in the laundry area. So let's go to the laundry area. And you see R5 is given to the washing machine. So here R5 is given to washing machine, 1 NOS. Okay, then we will go to Y5. Y5 again will be spare. And B5 also I can give as a space or spare. This I will also tell you in last how to calculate the number of spare and space in a particular DB. Now let us come to the R6 circuit. But before coming to the R6 circuit, we have completed the power circuit in the table. Okay, from R1 to B5. In this power layout, we just left only the FCUs, okay, which need to be tabulated. But we will tabulate the FCU load after completing the light load. And I told you also in my previous discussion that why we have choose the FCU later with the lights, because light and FCU have the similar ELCB sensitivity rating, that is 100 milliampere. Now let us start to tabulate the lighting load. The lighting load will start from R6, which I already discussed previously. So first we will check where is the R6 circuit in the lighting layout drawing. So here you can see that this is the kitchen, maid room, maid toilet and powder toilet room, which is fed from R6 circuit. So I wrote here R6 is fed to kitchen, maid room, powder room. Now let us move to the other circuit, that is Y6. Y6 is fed to the living and dining area. Okay, so I wrote here Y6 is fed in living and dining area. Then we will go to B6. B6 is fed to master bedroom area. Here you can see that B6. If I zoom it, B6. So B6 is fed to the master bedroom, its toilet and its dressing room. So I wrote here B6 is fed to master bedroom, toilet and dressing room. Okay, then we will go to R7. R7 is spare. We don't use anywhere R7. Now let us go to Y7. Y7 is in the kitchen, but you will not find here the Y7 because last time I told you Y7 I used for the hood. Okay, so Y7 is a hood circuit. If I'll show you also, I can show you Y7 is a hood circuit. You can see here Y7 hood circuit, number of quantity is 1. Now let us move to the B7 circuit. B7 circuit is given to the children bedroom. Here you can see that B7 is given to the children bedroom, its toilet and its dressing room. So I wrote here B7 in the bedroom 1, bedroom, toilet and its dressing. Now let us move to the other circuit, that is R8. R8 is FCU circuit. Here if you will refer the power circuit, then you will find that R8 is mentioned for FCU. So I wrote here R8. The FCU is placed in maid room toilet and it is feeding to the kitchen area also. So R8 is a FCU. If you will see, I mentioned the load here, 2 NOS FCU in the AC section. Okay. Now let us move to the other circuit, that is Y8. Y8 here is the circuit, light circuit, which is feeding the entrance, store and laundry area. If I zoom it here, Y8 is feeding laundry area, store area and the entrance. So I mention here. Now B8 is the FCU circuit. If you will see, B8 is a FCU circuit which is feeding the bedroom 1 and master bedroom. So B8 I mentioned here master bedroom and bedroom 1, and FCUs are placed in the toilet, so I mentioned toilet. And the total, the load is 2 NOS AC, single phase AC. Now let us move to the other circuit, that is R9 and B9, Y9. R9 and Y9 is a spare and B9 is a socket which is feeding to the telephone DB. Here I will show you. B9 is feeding to the telephone panel, that is B9. Now we have tabulated all the load in our load schedule. After completing the kitchen, I wrote maid room and powder room. Here maid room have 1 light, so I mention here 1. And we have in maid room and toilet 1 light. Okay, so I mention here 2, as these 2 light are same type of light, wet area light. I mentioned 2. After that I wrote 20 meter. This strip light is in a length of 20 meter. So I wrote here. In same way, I will give you one more example. After that, you have to follow others. So in living and dining area, I will here in living and dining area, we have 2 chandelier light and 1 balcony light in a circuit. So I mention here 2 and 1. And its corresponding loads also I mention here. This is the row 2 and 1. Corresponding loads I also mention here. The chandelier light have a load of 300 watts, so I mention here 300 watt. And the balcony light is 1 NOS and it has a load of 20 watts, so I mention here 20 watts. So you have to write in a sequence. I will give you one more example for more clarity. For example, bedroom, master bedroom toilet and dressing room. So let's go there. Here you can see that I wrote first 1. The 1 is for the master bedroom, that is for the chandelier light. Then I wrote 4. This is for the master bedroom toilet. In sequence, it has to be followed. First master bedroom, then the master room light, then the master bedroom toilet, then the master bedroom toilet light. Okay. So I mention here 4. 1, 2, 3, 4. Then I have a dressing room light, that is 2 NOS. This and this dressing room light. And I have a other type light in a dressing room, that is 10 meter. This is the strip light which is in length 10 meter. The corresponding loads also I mention here. For example, I will show you for the master bedroom. Here 1 indicated the chandelier light, so it is, and it has a watt rating of 300 watts, so I mention here. Then I mention the master bedroom toilet lights, that is 4 NOS, which having the watt rating of 22 watt, which I showed you in my previous lecture also. Then we have a strip light in the dressing room, which is 14 watt per meter. Here also I mention here 14 watt per meter. If you will watch my previous video, you will understand that how I wrote the load for the lights. Then we have 2 lights, okay, and it is, each light is of 18 watt. So I mention here 18 watt. In same manner, I have written the light types and its corresponding load for the entrance, store and laundry area. If you will check quickly, then we have 4 lights in the entrance, 1, 2, 3, 4, 1 light in the store and 1 light in the laundry area. So I mention here 4, 1, 1. If you will check its corresponding loads quickly, then I wrote here 18 watt, 18 watt, 22 watt. These 4 light of 18 watt store again 18 watt, and this light is 22 watt. Hope you understood how I wrote the room name in a sequence, then the number of lights in same sequence, and the corresponding loads also in the same sequence. Now let us check quickly the power layout and its corresponding load reflected in the load schedule. For the single socket, I already explained you. Now let us see oven. Oven is in the kitchen, and the corresponding loads of oven is, I mentioned here, 500 watt. If you will see in the layout, for oven, I mentioned 500 watt. In same way, if you will go for the microwave, then I wrote 1, and microwave load is 350 watt. So in the layout, if you will check, you will find that the microwave load I mentioned 350 watt. Apart from that, if you will check the washing machine, 1 NOS, which is in the laundry, and I wrote the washing machine load as 1200 watts. So here you can see that the corresponding loads I mentioned 1200 watt for the washing machine. For the water heater, I wrote 1500 watt. Here you can see that the load on the water heater is 1500. Apart from that, if you will check the water pump is 220 watt, which I mentioned here, 220 watt. I think it's a blur, but it is 220 watt. For more clarification, better you print this drawing and watch this video with that drawing. Apart from that, hob is 1 NOS and having the load of 6000 watt. So here in the kitchen, I mentioned before that the hob is 6000 watt. So far we have done how to write the room name as per the circuit number, and we also learn how to write the number of loads in the provided DEWA format for the power outlets and for the lights. Also we have learned how to write the unit rating for the load. Here you can see. Now we will find the total load on a R phase, Y phase and B phase for a particular circuit. So let's start this one. Here we can see that the main toilet and kitchen have 4 13 ampere socket, and the load assumed on one single socket is 200 watt. So the total load on R phase due to R1 circuit is 4 into 200, that is 800 watt. In same way, we will go for the living and dining area, which having 4 13 ampere socket. The load on each socket is 200 watt. So the total load on Y phase due to Y1 circuit is 4 into 200, that is 800 watt. In same manner for master bedroom, there is 6 single phase 13 ampere socket. The load on each socket is 200. So the total load on B circuit due to B1 circuit is 200 into 6, that is 1200 watt. In same way, we will check kitchen and bedroom for the 13 ampere socket. Now let us check R3 circuit, which is feeding in kitchen, and it is feeding to a load oven, and the load on oven is 500 watt. So the load on the R phase due to R3 circuit is 500 watt. In same way, Y3 is spare. B3 is feeding to the laundry area, and the load is washing water heater, and the load on the water heater is 1500 watt. So the load on B phase due to B3 circuit is 1500 watt. In same manner, we will go for the B4 circuit. B4 circuit is feeding to laundry, and it is feeding to a load of water pump. The pump load is 220 watt. So the load on B circuit due to B4 is 220 watt. In same way, for the R5 circuit, which is feeding in the laundry area, and it is feeding to washing machine, and the washing machine load is 1200 watt. So the load on R phase due to R5 circuit is 1200 watt. In same way, for the light, R6 circuit is feeding to kitchen, maid room and powder room, which having these light, and their corresponding loads are this. So here I will calculate one in order to understand it better, and later you can verify it by your own. Here 6 light into corresponding load, it is 300. Sorry, 6 light into 25. So it will be 6 light into 25 plus we have 1 light. The corresponding load is 22, and we have 2 lights. Its corresponding load is 18 watt, and we have 20 meter light, and its corresponding load is 14 watt per meter. So if we will multiply and add all the loads, then it will come as 492 watt. In same way, you have to calculate for each light circuit. I will give you one more example. For living and dining area, we have 2 chandelier light and 1 balcony light. Chandelier light load is 300 watt and balcony light is 20 watt. which I already explained in my previous discussion. So 2 into 300, that is 600, plus 1 into 20, that is 20. So it is 620 watt, which I mentioned here. Okay. In the same way, you have to calculate for other lights. Now, for the kitchen hob, we have one hob and the rating of the hob is 6,000 watt. So the load on Y circuit due to Y7 circuit is 6,000 watt. In R8 circuit is made toilet and kitchen, which is feeding to the FCU. I mentioned in the remark, feeding to the circuit, and the load on each FCU is 350 watts. So the total load on R phase due to R8 circuit is 700 watt. Same way we have to calculate. After getting the load on each phase due to every circuit, we will sum up the load on R phase, on Y phase, and on B phase. We will get to know that the total load on R phase will be 4,842. The total load on Y phase is 7,532, and the load on the B phase is 6,379. But from here you observe that the load is not balanced, meaning the load on each phase is not equal to each other. Deliberately I made this one because in future, if you are designing one load schedule and you encounter with such situation, then how you will deal it. So we will make it the DB balance DB, and then we will wrap this video. Okay. So here you find that the load on the Y phase is more compared to R phase and Y phase. The other thing you observe that if we will switch the Y phase load on the R phase, then the Y phase load will go down and the R phase load will increase, and it will catch the load near to the B phase. So here in our layout, what we have done, we have taken the Y phase for the living and dining area for the power socket, and for the light circuit also we use Y phase for the living and dining area. We cannot change one because if in a room we change the power socket, we have to change the light circuit also, as we cannot mix two different phases in a single room as much as possible. So what we will do, we will change this Y load to R load in R circuit, and this Y1 circuit to R circuit, R phase circuit. If we will do so, we will reduce this load from the Y circuit and we will transfer this load on the R phase. So let us change this Y circuit to R circuit in the lighting layout, and in power circuit this Y1 circuit to R circuit. Here you can see that in the power circuit, the Y1 is the circuit in the living room. So here there is living and dining area which have the 4 socket, each assumed load on single socket is 200. So total load on the Y circuit, Y phase due to Y1 circuit is 800 watt. We have to change this one. So I will copy it. Okay, and I will transfer to the red phase, but here I cannot transfer because already this load, already I use this circuit. So I have to choose a spare circuit. Okay, here you can see that in the last R9, we have one spare circuit. So I will copy here, living and dining area. I copied here, but this load I have to delete and transfer it to R phase, that is 800 watt. As I transfer this Y1 load on the R9 load, then I have to delete this load and the Y1 become as a spare. So I will write spare and I will delete its load. Okay, I will delete its load. Now for the lighting layout, Y6 we have to change into any R phase load. So here Y6 is living and dining area light. We have to copy this one correctly, and I have to change it to R phase load. Here you can see that the R phase R7 circuit is a spare. Okay, so we will copy here, and Y6 will become a spare. So we will change this one to spare and we will delete its corresponding loads. Okay, but where we copied in R7, this load is reflected in Y phase, so we have to change it to the R phase and delete this Y phase load. Now what we find here, after changing the Y phase to the R phase, we got a very balanced load, 6,266 in R phase, 6,112 on Y phase, and 6,379 on B phase. So this is the balance DB. I hope you got the clear idea if you encountered after designing that the load is not balanced, how to make it balance. Okay, in first time it will be difficult to do, but if you will practice, you will come to know. Now, after balancing the load between R phase, Y phase and B phase, let us understand how to write the CCT wire size and ECC wire size. During briefing of DEWA regulation related to light circuit and power circuit, I clearly told that the wire size required for the light circuit as per DEWA regulation is 2.5 square mm. So I mentioned here. So for the all light circuit, the wire size must be 2.5 square mm as per DEWA regulation. And during briefing of DEWA regulation, I also explained that when the phase size wire is less than 16 square mm, then the ECC wire size will be also equal to the phase size. As in our case, the phase size is 2.5 square mm, which is less than 16 square mm. So the ECC wire size will be same as of the phase wire. So here I mentioned the ECC wire size is 2.5 square mm. Now let us focus on the wire size of power circuit. As I told you during briefing of DEWA regulation that the minimum size for the wire in the power circuit is 4 square mm and it will increase depend on the load rating. I will tell you one simple thing that will help you during designing of any load schedule based on DEWA regulation, that if the load is less than 3000 watt, then we have to use 4 square mm wire. If the load is in between 3000 to 5000, then we can go for 6 square mm wire. Hope you are clear. Now we will see the load on each phase. The load on our phase is 800 watt, which is less than 3000. So we will use the wire size of 4 square mm. Okay, 4 square mm. The ECC size will be same as phase wire. Then the load on the B1 circuit is 1200 watt, which is less than 3000 watt. So the wire size will be 4 square mm. Then on the R2 circuit, the load is 800 watt. So the wire size will be 4 square mm. On the B2 circuit, the load is 1200 watt. Again, the wire size will be 4 square mm. In kitchen, R3 circuit, the load is 500 watt only. So the load will be 4, so the wire will be 4 square mm. For the B3 circuit, the load is 1500 watt. Again, the wire size will be 4 square mm. For the R4 circuit, the load is only 350 watt. So the wire size will be 4 square mm. And for the B4 circuit, the load is only 220 watt. So the wire size will be 4 square mm. In same way, for the R5 circuit, the load is only 1200 watt. So the wire size will be 4 square mm. In same way, in living and dining area, which is the R9 circuit, the total load on R9 circuit is 800 watt, which is less than 3000 watt. Then we can use a wire size of 4 square mm. Y9 is a spare, and B9 again, the total load is 400 watt only. So we will use the wire size will be 4 square mm. The simple rule is, I'll explain you once again. When the load rating is less than or equal to 3000 watt, then the wire size will be 4 square mm. Okay, and the MCB rating will be 20 ampere. When the load is between greater than 3000 watt and less than 5000 watt, then the wire size will be 6 square mm and the MCB rating will be 25 ampere. Select the MCB rating for each load. As I explained you that when the load is less than 3000 watt, then we will go for 20 ampere breaker. When the load is between 3000 and 5000, then we will go for 25 ampere MCB. And when there is a radial ring circuit, then we will go for 32 ampere breaker rating. So here in R1 circuit, the load is 800 watts, so the MCB rating will be only 20 ampere. For the Y1 circuit, it's spare, so we will use any rating. Let's say it is 20 ampere only. Here, the B1 circuit is a ring circuit, so the MCB rating will be 32 ampere. Now let us move to the R2 circuit. R2 circuit has the total load 800 watt, so the MCB rating will be 20 ampere as it is less than 3000 watt. Y2 is spare, so we will use any circuit breaker rating. Let us take 20 ampere. Okay. Now let's move to B2 circuit. B2 circuit is also ring circuit, which is feeding 6 single sockets. So the MCB rating will be 32 ampere. Now let us move to R3 circuit. R3 circuit is having a load of 500 watt, which is feeding to the oven. So with the load on the R3 circuit is less than 3000 watts. So the breaker rating will be 20 ampere. In same way, if you will follow the instruction, you will write down the MCB rating. Hope you are clear. Now let us move to the light circuit. As I told you, for the light circuit, the breaker rating will be 16 square mm. Now here with the light circuit, there is one circuit which is a power circuit and feeding to a hob, and the load on the hob is 6000 watt, which is greater than 5000 watt. So the wire size will be not be 4 square mm or 6 square mm. It could be 10 square mm or 16 square mm. So I mentioned here 16 square mm. You can write 10 square mm also, but with the safety factor I took 16 square mm, and the breaker rating as 45 ampere. Now let us move to the other circuit, that is R9 circuit. The total load is 800 watts, so the MCB rating will be 20 ampere. Y9 is a spare and B9 having a load of 400 watts, so the ampere rating for the MCB will be 20 ampere. So far we have selected the MCB rating for each load. We have assigned the wire size for each load. Now let us calculate or select the ELCB rating for each section. Here, which one is the lowest MCB rating in that section? It is 20 ampere. As 30, there is two type of MCB rating, 20 ampere and 32 ampere. Which one is the lower in them? 20 ampere. As I told you in my previous discussion that the ELCB rating will be double of the lower rating in that section. So it is 2 into 20, that is 40 ampere ELCB, and this loads all are power loads. So the ELCB sensitivity rating will be 30 milliampere. So I wrote here 40 ampere, 30 milliampere ELCB. In same way, in this section, the MCB lowest rating is 20 ampere, as there is no other rating, other MCB rating. The rating available is 20. So the ELCB rating will be double of the MCB rating. Then it will be 2 into 20 ampere, that is 40 ampere ELCB. And as it is feeding to the power circuits, then the ELCB sensitivity rating will be 30 milliampere. So I wrote here the same. In same way, in this section, the ELCB rating, the MCB rating is 20 ampere. So the ELCB rating will be double of the MCB rating, that is 40 ampere. And as all loads are power loads, so the ELCB rating will be 40 ampere, 30 milliampere. Now let us move to the other section. Here you can see that there is one MCB which having a rating of 20 ampere, and other two circuits are spare. So the ELCB rating will be double of the lowest MCB rating. Here there is only single MCB, so there is no concept of lower and higher. So it will be 2 into 20 ampere, that is the 40 ampere ELCB with the sensitivity rating of 30 milliampere, as it is also feeding to the load circuit. Now we have came to the section where light circuits are fed. So light circuit, the sensitivity rating of the ELCB is 100 milliampere, and the ELCB contact rating will be double of the lowest MCB rating. So the ELCB rating will be 32 ampere, 100 milliampere. Now let us move to the other section. Here the MCB ratings for this section is 16 ampere, 40 ampere and 16 ampere. So as per the rule, the ELCB contact rating will be double of the lowest MCB rating. So it will be double of 16 ampere, that would be 32 ampere. But I took here as a 40 ampere ELCB rating because one of the individual load in that section itself is a 40 ampere. So we should not write the ELCB rating lesser than its individual load. In other cases, if you will find all the individual loads are less than the ELCB rating. Here the maximum individual load is 32, but the ELCB rating is contact rating is 40 ampere. In this section, the MCB rating is 20, but the ELCB rating is 40. In this section, MCB rating is 20, ELCB contact rating is 40. In this section, the MCB rating is 16 and ELCB rating contact rating is 32. But in this case, if we will put 32 ampere, then the one of the MCB rating will be higher than the ELCB rating, which would be not a correct practice. That's why I put one higher rating. Hope you are understood with this point. Now let us move to the other section. Here the MCB rating is 16 ampere, so the ELCB rating will be double of the MCB rating, and in a next section the MCB rating is 20 ampere, so the ELCB rating will be double of the least MCB rating, then it will come as 40 ampere, and as it is a power circuit, it is feeding to the power load, so the ELCB sensitivity rating will be 30 milliampere. As we have completed the selection of the ELCB rating, now let us calculate the main incomer rating for the final distribution board. Here we see that the total connected load with this dB is 18.753 kilowatt. How we got this value? When we will sum this R phase load, Y phase load and B phase load, then we will get the total connected load, and I divided it by 1000, so we got this load in a kilowatt. In order to get the main incomer rating, we have to calculate the current requirement for this dB. How we will calculate this one? Here P we know, power we know. So we know that the three-phase formula for the power is P is equal to √3 into V into I into cos phi, which is a basic formula. I formulated here. P, here it's written 18753 in watt divided by √3, that is 1.732 into voltage V, three-phase dB it is, so 420 volt and power factor. If we will sum up, if we will calculate it, it came as 32 ampere. Okay. In order to select the incomer rating, we have to make one safety factor. So I took the safety factor as 1.25. So the main incomer rating came as, calculated rating came as 40.2804 ampere. So we can choose the standard rate, next standard available rating. So it will be 40 ampere triple pole isolator. If we will took the safety factor as 1.5, then it came as 48.3365 ampere, and the next higher isolator rating from the calculated rating is 63 ampere. In this case, we can take the main incomer rating as 63 ampere triple pole isolator. As I selected the safety factor as 1.25, so I choose the main incomer isolator rating as 40 ampere, which will be 3-pole isolator. Now, the last thing is balance in this designing is the cable size. In order to select the correct size of the cable, we have two options. One option is that we have to go to the deep discussion for the cable size calculation, which I already make a video on the cable size calculation. Link I will provide in the description of this video. But here we will go for the shorter method. We will just refer the DEWA regulation and we will select the cable for this dB. Here, as we see that our incomer breaker rating is 40 ampere. So when we will refer the DEWA regulation, here this chart is given for the multi-course cable XLPE insulated. So our MCB rating is 40 ampere, and in DEWA regulation, when the MCB rating is 50 ampere, then we can go for a 10 square mm of cable. So here we will choose 10 square mm CU XLPE SWA PVC cable, and with the earthing size of 1 core 10 square mm. Hope you got the idea. I know this video become very long, but if you will watch this part 1 video and part 2 video, you will have clear crystal knowledge for designing a final distribution board for any flat as per DEWA regulation. I hope you find this video informative and you enjoyed this video. If you really like this video, then please hit thumbs up button and kindly subscribe my channel. 90% of my viewers watching my video without subscribing it. So it is my humble request to subscribe my channel. It is motivating me to make such informative videos. We will meet in any other video. Till then, take care, keep learning, and bye-bye. Thank you so much.